Okay, so you're gonna go ahead and measure these for me? We're gonna start
Like,
with
do I
A.
need to take them out?
You can just do it in the baggie, it's fine.
Just in the baggie.
Yep, we wanna know how many millimeters we have there. Into the back of her head. So, what we're gonna do, guys, is we're gonna run a quick experiment to
about like
see
0.6
how
millimeters.
roundedness, how sorting, how size all affect water flow. And it might be surprising because some of those things affect it more than others. Okay, and then that'll let you answer the last question on the actual quiz online, okay? Got it? So if you come down here, or at least look this direction, I'm gonna write this up on the board here as we go. We have 5 baggies here, 1, 2, 3, 4, 5. The first one contains kind of sand, it's thick sand. Then we've got B is gravel, it's very angular. C is pretty rounded gravel, pea gravel. D is very unsorted, it's like a whole mixture of stuff, okay? And then E is marbles. So we're gonna test all this out. Okay, what do we have for A? What size is A in millimeters?
I believe 60 millimeters.
6 what?
60 millimeters.
16 millimeters? 60.
I don't know.
Should be.
Because I just know it tastes right.
Should be about. So each, just count each of these lines as 1. So that'd be like 5. So each little line is 5. So 6. Okay. So we got 6 millimeters for sand. It's pretty big sand. Okay, I give it.
And I think for me, that was like
120. So 18.
yeah, like
18. Okay.
I'm still doing the others because I had to move out of the way for her.
Okay. How about the pea gravel? The C. What size is C? Should be pretty close, I think.
1.17.
Yeah, so it's pretty close. It's about the same size as this. I did that on purpose. And then our mixture is everything from like 1 millimeter to like what? Like pretty big.
Yeah, it's pretty big.
Like
Near like 3.5, like 35.
so like near like 35
Like the biggest
millimeters.
one is like
There's some big chunks in there, and there's some stuff that's really tiny in there. Okay, and then E, the marbles are like 16. Okay, awesome. So we have different sizes. Let me pull that up. Let's talk about roundedness. So I gave you some pictures there, and you can see if you look at these, the sandy stuff is, if you look very close, is what we refer to as sub-rounded. So it's like not perfectly round, it's not a marble, but it's kind of somewhat rounded. Okay. The gravel stuff is super angular. This is some sharp, pointy, jagged looking gravel. It's very, very pointy stuff. I did that on purpose, okay? So this stuff is very angular.
So gravel that would especially for stuff to get in your eye.
You would not want that in your eye, no. You wouldn't want to fall down on it. Then we have the pea gravel. If you have pea gravel around your gutters at home, anybody have that on their house? This sort of, it's pretty rounded stuff. Like it's been rounded in a creek, but it's not as round as a marble. So we're going to go ahead and, that's pretty round. That's about as round as it gets in nature. So we're going to call this stuff rounded. Okay. Our mixture is, well, it's mixed. It's a little bit of everything. I mixed all these together pretty much is what I did.
Very rounded.
And you don't get any more rounded than marbles. Okay. Sorting. How well sorted is it? Well, the sand was all the same size, wasn't it? In fact, I sifted it on purpose to make it all the same size. So it's well sorted. The gravel was sifted. It's very well sorted. It's just angular. It's all the same, pretty much, pretty close. The pea gravel was also sifted. Those are all roughly the same size pieces. Now the mixed one is very poor sorted. Like that's the definition of poorly sorted, right? And then down here is about as good as you can get. It's very, very well sorted. Now comes the velocity part, the fun part. So we're gonna roughly measure the velocity of the water. I need to dump this out.